All right, so we are going to begin our first practical example, if there was ever something practical in math. So given that the graph f of x is equal to the absolute value of x. So here I have drawn the function f of x is equal to the absolute value of x. We're going to use transformations to sketch y is equal to the absolute value of x plus 1 plus 2. So just to recall from the previous video, and I think this is fairly important here, we have to understand that this, no, I'm forgetting what I'm saying here, but this is the form of transformations. So what is the value of h here? H is equal to -1. So this corresponds to h, and since it's x minus h, that would imply that h is actually -1 here, so that it could appear as x plus 1. The value of k is 2, because we shifted up 2 units. So we have identified the values of h and k. So let me just put that. Check. Good. So describe the transformations in words. Now I'm going to choose to use two different colors, maybe blue for the k and h is going to be red. Now does it matter which order h or k come in? Not yet, and we'll see why maybe in future lessons. So h is equal to -1. So h is equal to -1. What does that mean in words? In words, this means shift or translate 1 unit left. So the k is vertical, and since k is equal to 2, we're going to shift 2 units up. So now I'm going to graph the transformation. So I am going to choose to graph the shifting left 1 unit. So in essence, I simply take each and every one of these points and shift them 1 unit to the left. So I can take this one and I shift it 1 unit over to the left. Take this one and I move it 1 unit over to the left. I take this one and I move it 1 unit over to the left. Take this one, move it 1 unit over to the left. And I continue on. Now, naturally, there's going to be, you could have probably did this much faster than I did. You don't have to actually take every single point and shift it 1 unit to the left, but it just creates something that looks a little bit nicer here. Thankfully, you are using a ruler, but me not so much. Now, I put arrows at the end. I guess I should assume that I'm going to put arrows at the end of this too. I apologize, but there. I have shifted my graph 1 unit over to the left. And now I'm going to shift this red up 2 units. We always shift transformations one after another. So up 2 units, and I take the points up 2 units, up 2 units. There we are. If you notice, I skipped this one. I'm feeling fairly confident now. Up 2 units. And in fact, oof, it's really hard for me to draw that way, but that's what my function looks like. Please use a ruler. Anyways, now I'm going to use mapping notation. So really, mapping notation tells us, how did this graph change? Well, this graph started off with point xy, and that was on f of x. So you may want to write y is equal to f of x. Maybe I should have put that in black. And then it got transformed into y is equal to f x plus 1. Shifted over to the left 1 unit, and what happened there? Well, we took all of the x values and we shifted them over 1 unit, so in the y value stayed the same. Now, for our final transformation, we had y is equal to f x plus 1. Now, I needed to shift this up 2 units, so I'm just going to put plus 2. So what we have is x minus 1. So the x values are from the red. We borrowed those, and we simply just added 2 to each y value. I hope that helps. So again, here's h and k. I identified those. Then in words, I put it into words and said, how did these graphs change? Last but not least, I changed the function, the way the function looks, and this is my point notation that I use to transform functions. All right, let's move on. So the parent function, example, the parent function f of x is equal to 1 over x squared. Now you may recall that from last year, 1 over x squared is really this curved brown line. We're going to choose points or ideas from the apparent function, and we are going to locate the translated image points. So we're going to determine the equation of the translated function in the form f of y is equal to f x minus h plus k, and the equation of the function in standard form. Fair enough, that's asking a lot. But this is a very special type of function that we took a look at last year, I believe. And it is right here. Right? This is the one that we're talking about. And in fact, you may be able to spot out from last year that this is a rational function. So what are some ideas of a function? To me, the easiest idea to spot out is the vertical and horizontal asymptote. So just in blue, I've just highlighted the vertical and horizontal asymptote. That will give me a pretty good indication of what's going on. Now I'm just going to switch my colors to the green graph. So the brown graph is our parent function. The green graph is going to be my transformed function. So there we have our new vertical asymptote. My horizontal asymptote for this So let's take a look. How did I change the blue horizontal asymptote to be the green, right? So the brown graph almost looks like it was shifted up diagonally. But really, instead of diagonally, we can take a look. It was shifted across horizontally and then up. So here, how can I change the horizontal asymptote to become the green one? Well, k is equal to 2. Well, how do I move the blue vertical asymptote to become the green? Well, that is a shift horizontal to the right. H is equal to 3. So choose important points or ideas from my parent function and locate the translated image points. I think that I've done that. It hasn't asked me to graph the transform function. In fact, I was given that. Determine the equation of the transform function in the form y is equal to f x minus h. So very simply, I'm just going to say y is equal to f x minus h, so minus positive 3, close brackets, plus k. Now, if I chose to write it as a rational function, I'm just going to switch. So now this is in translated function form. I'm just going to write it as a rational function now. So y is equal to 1 over, what's happening to the x, right? So if you notice, the h still stays with the x. So I'm just going to put that in brackets. These brackets aren't needed, but they sort of help me conceptualize what's going on. And then plus 2. All right, good times, right? Anyways, last but not least, I believe this is the last question. Choose important ideas from my parent function to locate the translated image points. So I'm just going to, right now, I don't know which is my parent function and which is my transformed function. So I'm going to call this my parent function. I'm going to write my parent function, and I'm going to change this to black, and I'm going to call this y is equal to f of x. So right now, I am going to be saying that this is where I want to start. I need to move it or translate it so it becomes this. So I have to locate the key points or the important ideas. Here's my key point. There's a little ridge right there. I can see it's corresponding to that ridge. Right here also corresponds to maybe right here. And we sort of see it has the same point, and this is going to be hopefully relatively easy. Now I can call this point A, for example. How did point A become A prime? A prime just simply means the transformed point. Well, I move up 1 unit, I think, right? And then I move this over that far. So up 1 over 1, 2, 3. So what I get is h, k, h, it's to the left, so it has to be -3. K is going to be moving up 1, so k is equal to 1. So in function, like, what is the equation of this function? I have no idea, but I can still communicate the idea of the transformation in the general function form. So we start off with y is equal to f of x, and this got changed into y is equal to f x plus 3 plus 1. If you choose to write the point notation, you would start off with point x, y. How did that get transformed? That get transformed into point x minus 3. My y values, we just added 1. I hope this helps. Good luck. If you have any questions, make sure you ask in class. Now, let me just go over very quickly the main ideas. Very, very quickly. I'm going to time myself for 1 minute. We have these things called transformations. And in essence, they move the graph up and down. And we denote the points up by the parameter k and horizontal by h. And this table is really helpful in determining that. What we see is the graphs moving up and down. Things that I would like you to focus on are determining the values of h and k, describe the transformations in words, graph the transformation, and get used to this really weird mapping notation. I think where most of us will have a hard time with is h. So let's really flesh that out in class. What is h? And otherwise, good luck to you. Have a good evening.